Please welcome Dr. Raman Singh of Shinyatech to the stage.
Good morning. Let's try that again. Good morning. Now, before you think I've completely lost my mind and lost track of time, I know we've all been listening to a lot of things going on today. I want to ask the 5 people who answered back good morning what is going on in their minds. I'm Raman Singh. I'm going to talk to you about Shinyatech. I will tell you about one project that we are working on. It's based on our core technologies. And perhaps most importantly, I'll tell you who we are and what our perspective is on what we do. Our basic mission, our core mission, is to take innovative technologies and bring products to the marketplace that at the same time improve the life of the common man. And this is what drove the naming of the company. Shinya is actually based on a Japanese word that means pure or fresh or innovative. So it was not some just numbers or words that we made up. To tell you what we've been working on recently, I'm going to take you on a road trip. It's not going to be one of those road trips. It was actually a road trip I was on in the late 90s, and I was going to visit Death Valley National Park. It was late fall, about a month later than what it is now. And it was hot. It was incredibly hot, and I knew exactly how hot it was because at that time, the only car I could afford didn't have any air conditioning in it. So the windows were rolled down, and they say it's a dry heat, but trust me, it is hot. So as I was with a bunch of friends, as we were going over in the desert, in the California desert, we come over this hill, and as we come over this hill, I see this sight to me which was incredibly beautiful. And when I say to me, you have to remember that at heart I'm a mechanical engineer. So what we saw over the hill was these wind turbines. And this is the first time in my life that I had seen a wind turbine farm. These are incredibly big, beautiful machines moving in the wind. And the principle is utterly simple. You use the wind to generate electricity. Why is this important for us? This is a composite image that was put together by NASA by imaging the Earth at night. Now, you have to remember that 50% of all the energy that we generate is used to generate electricity. If you look at this picture of the world and you see what parts of the world are lit up at night, those are the parts of the world where there is significantly higher quality of life and significantly higher economic development. Invariably, at the end of the day, your quality of life depends on the energy you can generate and the energy you consume. And wind turbines play a role as far as the energy diversity of this country and, more importantly, the whole world is concerned. And these are, I said, these are big, beautiful machines. Now, these are not exactly to scale, but the biggest wind turbines today have a height of about 220 meters. And that's a few meters higher than the BOK Tower in Tulsa. So you'd get all excited, and this is fantastic. But all is not well in paradise, as they say. The problem is if you don't maintain these machines, you run into trouble. You don't maintain anything, you run into trouble. But if you keep things going, and these are 2 cars, this is, I believe, a 31 Studebaker, and this is a 28 Model T. And both pictures were taken about 2005. If you maintain something, you can keep them going. So wind turbines have run into problems with maintenance. They need to be maintained. Some of these problems were not foreseen when they were put up, and one of the problems that was not foreseen when they were put up was leading edge erosion. These wind turbine blades are sweeping through the air, and as they sweep through the air, they sweep through everything else that air carries. Bugs, hail, storms, dust, sand, and they move through pretty fast. The tip of a wind turbine blade can move as fast as 180 miles per hour. They're being exposed to this environment day in and day out whenever they're generating electricity. And as a result, the edge of the wind turbine blade gets eroded. This is a very severe picture that happens after a long time, but what happens initially in the life of the wind turbine is as soon as you start getting some erosion, you start changing the characteristics of the wind turbine. And that causes losses in efficiency. That actually causes the bearings in the generators to fail faster than they would otherwise. And this is where we come in. So when I took that road trip, the one thing that stuck in my mind was the heat and seeing these wind turbines operate in the heat. And it was one of those thoughts. It was like a little depth charge dropped into my mind that didn't surface almost a decade and a half later. There was a PI at Shinyatech who was working on an NSF SBIR project dealing with ceramics, and we were talking about trips, and I brought up this trip, and we were talking about wind turbines and the heat. And you have to realize I've been in Oklahoma several years now, so I'm getting acquainted with the heat again. And he and I basically ended up with this concept that why don't we take our ceramics technology and adapt it to the leading edge problem of wind turbine blades. Now that's the technical part. Now the entrepreneur part of me is thinking, yeah, but who will buy it? So you start looking into the problem. 2010 is the first year when wind turbine leading edge erosion is identified, and 3M launches a study into seeing if this is a real problem. They realized that you put a new wind turbine in the field, it takes 2 to 3 years for the leading edge problem to occur. So you have to go out and essentially repair a wind turbine every 2 or 3 years if you repair it with the materials that the blades were originally made of. A wind turbine is expected to last 20 to 25 years. Each time you go in and repair the blades of a wind turbine standing in the field, you spend close to about $100,000. And this is for wind turbines that are standing out near Amarillo, Texas. If they're standing out offshore, the costs are astronomically higher. So how do they repair wind turbine blades right now that are subjected to leading edge erosion? They essentially put paint on, they put a polymer tape on at the leading edge of the wind turbine. All that does is that takes the problem and offsets it 2 years in the future because the polymer tape again wears down. It's a good model as long as there isn't any other solution. What we've been able to figure out and do is put ceramic coatings on these leading edges of wind turbine blades. The material is much harder, much more wind resistant, and our preliminary data shows that our coatings will last at least 2 to 4 times as much as the polymer tape coating. So instead of having a problem of repairing wind turbine blades every 2 to 3 years, you're looking at every 4 to 10 years. And that's a huge savings because the primary cost is getting out to the wind turbine and working on the blades. Where does our innovation come in? Our innovation comes in that we can do this in the field while the blades are on the turbine. Anybody can put a ceramic coating on a wind turbine blade. If they're in the lab, we can do it out in the field. So we have to take this idea, which is a nice technological concept, and then bridge the gap magically to make a product that sells in the marketplace. And this is an image of one of the first coatings we made. I didn't even know that. This is not me, by the way. This was the PI. He was going through a Harley-Davidson motorcycle riding phase in his life, as you can see. And this was the first image. They took the image. I never even knew that this was going to be presented later on, but this is the first time I've showed this image. So how do you take this and bring it to something real in the marketplace? And what we figure out is that you have to aim high. You have to believe that it is going to all work out. And you have to believe it almost stupidly because, when they ask Sir Edmund Hillary why he climbed Everest, and that's a picture of Everest from a plane, his answer was because it's there. And the way he climbed Everest is the way you do anything else, or the way we believe everything else is putting one step ahead, 1 foot ahead of the other. And we have to remember that it has to be fun. The moment it stops being fun and the moment it turns into a chore for us, then it's not worth doing. So we've been working on this. We work on some other ceramics technologies. We enjoy what we do. And that helps us put up with a lot of sleepless nights, and sometimes we get on each other's nerves, and that's the day to call it a day and go out and have a beer. Thank you very much.